Hello, welcome to the introductory video about direct current circuits. This will be the first of either 2 or 3 videos depending upon your level. The first, we're going to do a large series of interactives about circuits, not only analyzing them but also building them. So I'm going to focus on something that we won't talk as much about in class directly, and that is, well, that's 2 things. One is looking at the internal resistance of a battery, because a battery produces this electrical energy, but there's a cost to it. The electrons, as they're given this energy, also it's not 100% efficient, so they give it off as heat. I have a video that I will play after this that shows that in a lot more detail. Before I show you that video, the one other section that you're responsible for and you're going to read about is how do we measure the things we want to measure in a circuit. And we use what's called an ammeter and a voltmeter. In class, these are all in one meter called a digital multimeter, but they can actually exist also in separate meters. An ammeter is used to measure current. It has a resistance equivalent to the wire that it replaces, so it does not affect the circuit, and it would be measured the current that actually flowed directly through it, so it would have to be put in what is called series. A voltmeter measures voltage or potential difference, and so it measures the potential difference of the charges, how much energy each charge has, the difference in that amount on one side of an element compared to the other side of an element. You used a voltmeter in the electric fields lab to measure some of the potential differences there. But so a voltmeter measures voltage across an element, or change in potential, sometimes called potential difference, and an ammeter measures current through it. So now here's a short video about the internal resistance of a battery.
Okay, finding internal resistance and EMF of a cell. Now, if we start with a simple circuit like the one shown here, it's got a battery, a single resistor, and an ammeter connected all in series. It appears that there's only one resistor, whereas actually we now know there are not a single resistor. There's also a resistance inside that cell itself, inside that battery itself. Those electrons, they're being pushed through by the chemical reaction going on between the acid and the 2 metals in there. They find it difficult, so they're losing energy. Not only are they given energy, but they actually lose some in the battery itself. You'll know this because if you ever touched a battery that's been on for a long time, it gets hot. Therefore, electrical energy is being converted into heat energy. So we can represent that battery, instead of just a single battery circuit diagram, circuit symbol, we can use this notation here. So the little r, the small resistor there, is a symbol that's always used to indicate internal resistance. The cell to the left, that's where the EMF, that's the thing that gives the electrical energy, so gives the energy per Coulomb charge. Or we get the potential difference across the external resistor. The potential difference also is energy lost across the internal resistance, and we can see the terminal potential difference, terminal voltage, which is actually the same as the potential difference across the resistor as well. What do we know about this